Have you ever wondered how vehicle chips are made? This seemingly simple question opens up a world of intrigue and technological innovation that lies at the heart of modern automobiles. These chips, also known as microcontrollers, are the unseen conductors orchestrating the symphony of systems that make our cars run smoothly and safely. Imagine a city. Picture its traffic lights, the subway system, the power grid, all working in harmony. Now shrink that city down to the size of a fingernail and you're beginning to understand the complexity and importance of vehicle chips. Just like a city's infrastructure, these chips control a multitude of functions, ensuring everything runs like clockwork. Take the engine, for instance. It's not just a hunk of metal, it's a finely tuned instrument. The vehicle chip is the maestro, conducting the engine's performance, adjusting fuel injection and ignition timing, and even monitoring emissions. It's a task of such precision and complexity that it simply wouldn't be possible without these tiny silicon wonders. But the role of vehicle chips doesn't stop at the engine. They're the silent guardians of our safety systems, controlling everything from anti-lock brakes to airbags. They're the brains behind our infotainment systems, making sure our favorite tunes play without a hitch and our GPS navigation guides us to our destination. And let's not forget their role in the burgeoning field of electric and autonomous vehicles. Here, vehicle chips are more critical than ever, managing battery systems, driving aids, and a host of sensors, bringing us closer to a future where cars drive themselves. So here we are, standing at the edge of a silicon city, marveling at the sophistication of these tiny chips. Yet, the question remains, how does a tiny piece of silicon control such complex systems? It's time to pull back the curtain and delve into the fascinating process of making vehicle chips. Let's embark on this journey of discovery together. The journey of a vehicle chip starts with a simple element, silicon. This abundant element, second only to oxygen in the Earth's crust, is the primary ingredient in the creation of chips. But it's not as simple as digging up silicon and shaping it into a chip. No, it undergoes a fascinating transformation that is both a marvel of human ingenuity and a testament to our relentless pursuit of technological advancement. First, raw silicon is mined and purified. It's heated in a furnace at temperatures reaching 1400 degrees Celsius, where it reacts with carbon to form a very pure form of silicon. The purity of silicon is of utmost importance because even a tiny particle of impurity can disrupt the delicate electrical properties of the chip. After the purification process, the silicon is then formed into a round ingot. This is done through a process called Czochralski growth, where a tiny crystal of silicon is dipped into a molten pool of pure silicon and then slowly pulled up, causing the silicon to solidify and form around the crystal. The result is a cylindrical ingot of silicon as pure and flawless as can be, but we're not done yet. This ingot is then sliced into thin discs, or wafers. These wafers are mirror smooth and incredibly flat, with a thickness that can be less than a human hair. Achieving this level of precision is crucial, as any variation in thickness can lead to defects in the final chip. The wafer then undergoes a series of treatments to prepare it for the next steps. These include cleaning, polishing, and heat treatments to ensure the wafer is absolutely perfect. It's a meticulous process where even a single speck of dust can spell disaster for the chip. And there you have it. The birth of a silicon wafer, the canvas upon which the intricate designs of a chip will be etched. With our silicon wafer ready, we can now begin the intricate process of chip fabrication. The heart of chip making lies in a process called photolithography. Let's dive into the fascinating world of photolithography, shall we? This process, which is as mesmerizing as its name, is all about sculpting the chip's design on a silicon wafer. It's akin to an artist painstakingly crafting a masterpiece, but here, the canvas is a wafer and the brush, a beam of shining light. We begin with coating the silicon wafer in a light-sensitive material called photoresist. Think of this as preparing the canvas before splashing on the colors. This photoresist is the key to our artistry, reacting when exposed to light and allowing us to etch intricate designs onto the wafer. Next, we project an image of the chip's design, a blueprint if you will, onto the silicon wafer. This is done using ultraviolet light and a mask, which is essentially a stencil of the chip design. The mask is placed over the wafer and the ultraviolet light is shone through it. The light transfers the design from the mask onto the photoresist-coated wafer. It's a bit like using a projector to display an image onto a screen, but on a much smaller scale. The areas of the photoresist exposed to the light undergo a chemical change. Depending on the type of photoresist used, a positive or negative, either the exposed or unexposed areas will become soluble. This solubility is crucial for the next step of the process, etching. The wafer is then submerged in a solution that removes the soluble areas of the photoresist, revealing the silicon underneath. This is where the magic of etching happens. The exposed silicon is etched away, leaving behind the parts covered by the photoresist, and voila! We have the first layer of our chip design etched onto the silicon wafer. Now this process is repeated multiple times with different masks for each layer of the chip's design. Each layer is etched onto the wafer, one atop the other, until the full design is complete. It's a meticulous process and one that requires immense precision and accuracy, because remember, we're working on a microscopic level here. Even the tiniest error can render the chip useless. But when done correctly, photolithography allows us to create incredibly intricate designs, with features as small as a few nanometers. That's thousands of times thinner than a human hair. It's quite mind-boggling when you think about it. And there we have it. After many repetitions of this process, we have a multi-layered chip, but it's not ready just yet. Yes, you guessed it, there's more to the art of chip making, but that's a story for another scene. After many repetitions of this process, we have a multi-layered chip, but it's not ready just yet. Our chip now needs protection and a way to connect with the vehicle's systems. This is where chip packaging comes into play. It's like wrapping a precious gift, where the gift is our chip, and the wrapping is a protective casing designed to shield it from the harsh conditions it will encounter in a vehicle. Chip packaging involves encasing the chip in a durable material to protect it against physical damage, heat, moisture, and other environmental stresses. It's a crucial step in the chip-making process because, without it, our chip would be vulnerable to damage, which could lead to malfunctions, short circuits, and other undesirable outcomes. In a vehicle, where temperatures can fluctuate wildly and vibrations are a constant, the importance of this protective shell cannot be overstated. But protection is not the only function of this packaging. It also serves as the bridge between the chip and the vehicle's systems. You see, it's not enough for our chip to be a master of computations. It needs to communicate its results, to interact with the rest of the vehicle. This is achieved through connection points, also known as leads. These are essentially tiny wires that extend from the chip through the packaging and out into the world, ready to transmit signals and power between the chip and the rest of the vehicle. Creating these leads is a delicate process requiring precision and care. They need to be robust enough to maintain a stable connection, yet thin enough to fit within the compact confines of the chip package. It's a balancing act of engineering and design, a testament to the meticulous nature of chip manufacturing. So, we've encased our chip in a protective shell and we've given it a means to communicate with the outside world. What we have now is a fully formed chip, a marvel of technology ready to take its place in the heart of a vehicle. But we're not quite done yet. There's one more step before our chip is ready to roll off the production line and into the world. Now our chip is fully formed and ready to be tested. Before a chip can find its way into a vehicle, it has to pass rigorous testing. Now, what does this testing entail? It's a fascinating process, really. The first step is functional testing. This is where the chip is checked to see if it's performing its intended operations. Picture it as a final exam for the chip, where it has to demonstrate that it has learned everything it was designed to do. Next, we have environmental stress testing. This is where the chip is subjected to extreme conditions. It's like a survival camp for the chip. The chip is exposed to high and low temperatures, vibration and humidity. The idea here is to simulate the harsh conditions a chip might encounter inside a vehicle. After all, a car isn't always parked in a comfy garage. It ventures out into the blistering heat of summer, the freezing cold of winter, and everything in between. Then comes the life test, also known as the endurance test. This is a long-term test that checks the chip's reliability over time. Think of it as a marathon for the chip. It's not just about whether the chip can function, but whether it can keep functioning over a prolonged period. Lastly, we have the electrical testing. This examines the chip's electrical properties to ensure it is safe to use. It's like a health checkup for the chip, making sure there are no electrical issues that could cause problems down the line. Each chip is subjected to all these tests, not just a random sample. That's because even a single faulty chip can lead to serious issues in a vehicle. The stakes are high, so the quality control must be rigorous. This testing and quality control process is crucial. It ensures that every chip that ends up in a vehicle is reliable, durable, and safe to use. It's a testament to the meticulous attention to detail that goes into making vehicle chips. Once a chip passes all these tests, it's ready to be integrated into a vehicle. Now that our chip is ready, it's time to put it to work. This little marvel of technology that we've painstakingly crafted finds its home in various vehicle systems, quietly working behind the scenes to ensure everything runs smoothly. In the engine control unit, our chip flexes its computational muscle, processing data from numerous sensors to optimize performance, fuel efficiency, and emissions. It's the maestro conducting a symphony of pistons, spark plugs, and fuel injectors, harmonizing them into a smooth ride. Our chip also finds a place in your vehicle's infotainment system. It's the unseen DJ spinning the tracks on your road trip playlist, the invisible guide plotting your GPS course, and the silent operator managing your hands-free calls. But the role of chips in vehicles doesn't stop there. In advanced safety systems like anti-lock braking, stability control, and airbag deployment, our chip stands as a vigilant guardian, ready to react in the blink of an eye to keep you safe. Looking ahead, the future of vehicle chips is as exciting as it is promising. With advancements in autonomous driving, our chip could soon take the wheel, navigating traffic and making decisions with higher precision and faster reaction times than a human driver ever could. In the realm of electric vehicles, our chip's role becomes even more critical. Managing battery efficiency, optimizing energy regeneration, and ensuring the seamless interplay of electrical and mechanical systems are but a few of the tasks our chip will shoulder. The possibilities are endless, and the potential is truly staggering. As chips become more powerful, more efficient, and more intelligent, they will continue to revolutionize the way we drive and experience our vehicles. So next time you marvel at your car's smart features, spare a thought for the tiny chips that make it all possible. Vehicle chips may be small, but their role in modern vehicles is enormous. These tiny components, often overlooked, are in fact the heart and brain of our vehicles, making every journey safe, efficient, and enjoyable. We've journeyed together through the intricate process of how these chips are born, a process that starts with a simple slice of silicon. This silicon wafer, as we've discovered, is not just a piece of metal, but a canvas on which the blueprints of complex electronic circuits are etched. This is the art of photolithography, a process as precise and meticulous as watchmaking. These etched silicon wafers then go through a transformation as they are packaged to protect the delicate circuits within. Like a knight in shining armor, the package safeguards the chip from the harsh conditions it will face in the vehicle, while also providing a bridge for it to communicate with the outside world. The final stage, testing and quality control, is where the chips are put through their paces. Rigorous tests ensure that each chip can perform its function reliably, even in the most demanding of conditions. Once these chips pass the tests, they are ready to be integrated into vehicles, where they control everything from engine performance to safety systems. The future promises even more as vehicle chips evolve and become more powerful, paving the way for autonomous vehicles and smart transport systems. So, the next time you get into your car, take a moment to appreciate the technology that makes your journey possible. Remember the complex processes that go into creating the chips that power your vehicle, and marvel at how something so small can play such a huge role. From a simple piece of silicon to a powerful vehicle chip, it's quite a journey, isn't it?